Okay, it's recording, and let me check. Yeah, recording the same display. Okay, now the length of a simple pendulum is 65 centimeter, and it is released at an angle 6 degrees to the vertical. Calculate the period of oscillation. So this is about simple pendulum. Okay, so is this about mechanical wave or just one particle? Is this oscillation of one particle or oscillation of many particles, class?
One particle.
Just one particle. It's talking about simple pendulum. Simple pendulum means this one lah, just one particle. Okay, just one particle. It's not about what we have just learned about the water wave. Yeah, with many particles. It's not oscillation of many particles. Okay, so it's simpler. For simple pendulum is simpler, just one particle, and the equation is just plus minus is just omega t. Yeah, for one particle. We don't have plus minus kx. Don't have. Okay, so for one particle, very simple. Kalau many particles, then only becomes where is the equation? Then only got plus minus kx. Okay, kalau satu particle sahaja, like simple pendulum, is just omega t. No, tak ada plus minus kx. Okay, so formulanya inilah, just omega t saja. Ya, formula itu. Okay, back to this question. So now the length of a simple pendulum. Yeah. So I just want to write this is about one particle oscillation SHM, and then he give you the length. This is length L. But unit, be careful with the unit. Centimeter, you need to change to meter. Okay, so the length is 0.65 meter. Okay, change to SI unit. Okay, release at 6 degree. Okay, and then calculate the period of oscillation. Okay, period. So simple pendulum period. How to find period for simple pendulum? There's one formula. Remember? What formula for period?
Pi.
Yeah.
Of 1/G.
Yes, period is 2 pi square root L over G. This is it. Yeah. If spring mass is 2 pi square root M over K. Yeah. Square root M over K. Kalau simple pendulum is L over G. Spring mass is M over K. Okay, use that. So question A. So I can find my period for simple pendulum. L over G. Okay, and then L. I've changed to SI unit already. So okay lah, 0.65 meter. Yeah. And then gravity is 9.81 meter per second square. Okay, I need answer.
1.62.
Oh, good. 1.62 kan?
Yeah.
Okay, that's good. Second, unit for period is second. And then question B. Calculate the pendulum's bob speed and acceleration when it passes through the lowest point of swing. Lowest point of string. Let's draw it out. Let's draw out the simple pendulum first. Simple pendulum. Okay. Lowest point. It oscillate. So at lowest point actually is this is the equilibrium kan? Betul tak?
Betul.
Kalau di sini amplitude. Sini negative amplitude. So this is the equilibrium position. So lowest point means over here. Okay? So lowest point the equilibrium. Maksudnya ini speed ialah maximum or minimum at lowest point. The speed is maximum or minimum at lowest point. Di equilibrium lah ni maksudnya. Kelas? Kalau di equilibrium dia punya velocity maximum ke minimum?
Maximum.
Maximum. Masih ingat itu simulation hari tu saya tunjuk? Nak buka lagi. Nak buka lagi. Tengok velocity maximum di equilibrium kan, betul tak? Kinetic energy pun maximum kan? Ini spring mass. Tapi kalau simple pendulum sama tak? For simple pendulum, is it the same? It's the same lah. Kalau di lowest point, dia pun di equilibrium juga kan? Dia equilibrium dengan equilibrium di sini sama. So they have the maximum speed. Tengok the orange line. The orange line is longest at equilibrium. Correct or not? So V max di mana? V max di mana? Equilibrium. Okay? V max di equilibrium. So di sinilah V max. Di sini V0, betul tak? Di amplitude V0 kan? Betul lah, you bayangkan pendulum ni berayun kan, dia berhenti sekejap di atas. Di sini kinetic lowest point kan? Biasanya kita cakap lowest point mempunyai kinetic energy paling tinggi kan? Kalau highest point kinetic energy jadi kosong, betul tak?
Betul, sir.
Okay? So dia benar kinetic energy maximum di sini. So velocity maximum. Okay, how about acceleration class? Kalau acceleration pula macam mana? Okay, kalau displacement maximum di amplitude kan dia punya acceleration is proportional to displacement kan? Negative omega square y kan, betul tak? So kalau displacement meningkat, acceleration pun meningkat kan? Tengok di sini. Tengok itu red line and blue line. See that? Kalau blue line menjadi kosong, acceleration pun jadi kosong kan? Bila blue line menjadi paling panjang, acceleration pun paling panjang. Acceleration is proportional to displacement. That's the meaning of simple harmonic motion. The meaning of simple harmonic motion itself, the definition of it. Kan saya sudah ajar dari awal lagi. See that? I don't want to repeat this again. Yeah. You want to repeat? You go to my video. There we repeat 100 times again. Okay, so you can see that. So apa boleh kita kata acceleration maximum di mana? Acceleration maximum di mana? Kelas?
Y equal to M.
So A maximum di sini. Cuma opposite direction kan?
Ya.
A kosong di sini. A kosong di sini. A kosong di... Kalau Y kosong, Y kosong, A pun kosong. A pun kosong, Y kosong, A pun kosong. Kalau Y maximum, A pun maximum. Tapi opposite direction lah. Opposite direction. Okay? So sekarang kita nak apa di mana? Kita nak di mana? Lowest point. Lowest point means dekat Y equal to 0 sahaja. So Y dekat 0. So boleh tak you cari V maximum dan acceleration? Acceleration 0 lah. Nak cari speed means tak payah direction pun. Speed je. Magnitude je. Okay. So at Y equal to 0, equilibrium. V is maximum. Positif negatif pun boleh. A omega. Kan dia punya formula A omega kan V maximum. Masih ingat?
Betul.
Okay, V maximum is A omega. See that? Acceleration maximum is A omega square. Kalau Y maximum A omega square. Very simple to remember. So V maximum is A omega. What is our A? What is our A? Oh, no A How? Release at 6 degree to the vertical. That means it release. So maksudnya dia release dekat mana? Dia release dekat this is the point it release kan? So it release from here, so it will oscillate also from here kan? Kalau dia release at, that means 6 degree to a horizontal. That means this is 6 degree, betul tak? Class.
Yes.
So 6 degree. So kalau dia release 6 degree, dia oscillate pun oscillate 6 degree. Adakah dia akan oscillate lebih banyak? Oscillate kepada 8 degree nanti. Tiba-tiba dia oscillate 8 degree, boleh kah?
Tidak.
Tidak boleh. So kalau you release dari 6 degree, means dia pun oscillate dalam 6 degree je lah. So the point you release is the point of amplitude. Release, kita boleh kata release from amplitude. Because that is the amount of gravitational potential energy you provide for the ball. So kalau itu amount of energy you provide for the ball, dia pun akan oscillate pada potential energy itu. Dia tak akan oscillate more than the gravitational potential energy you provide. You understand? So you release from 6 degree, dia bukan oscillate at 6 degree lah. So released. So this is the amplitude. This is the amplitude. So 6 degree. So how? Okay, wait. How to find the amplitude, class? Use your creativity. When I ask use your creativity, that means you think. Dia bagi nilai apa kepada kita? 6 degree. Selain 6 degree, apa lagi nilai dia bagi kita? Amplitude, that means amplitude. Another key I give for you. Amplitude means this length lah. Ayah. So this is amplitude. Apa lagi dia bagi kamu? Ya, tadi Haslina cakap length kan?
Ya.
So boleh tak you rasa cari amplitude? Macam mana cari amplitude ni? Cari nilai ini, amplitude. Macam mana? This is a straightforward question. You should give me a straightforward answer. How come I need to wait so long? 5 seconds, 10 seconds has passed because I comment some more. So what is the amplitude? Class, if you know the answer, you give me the answer straight away. No need to wait. No need to wait for, you know, the most brilliant type of students should answer this question. No. Don't wait for the typical students to answer such question. No. Yeah. If you know the answer, share lah. Share your answer. Be open-hearted. Yeah. Don't know kah? Or you really don't know? Macam mana nak cari amplitude ni? Bila diberi hypotenuse, ini hypotenuse kan?
Ya.
So, ini hypotenuse kan? Hypotenuse, ini opposite kan? So, ada angle lagi kan? So, apa kita buat ya? Don't like, you know. Okay, there always be a smarter student than me to answer such question. So I will just wait for him. No, not like that. If you know the answer, you straight away tell us. No need to wait for certain students to answer the question. No, that's not the mindset. Yeah. When you answer, you save the time so that we can discuss more question. Yeah, save the time. Yeah, you answer the question, not mean you show off. Show off. No, it's not about showing off. Yeah, it's not about showing off. It's about sharing. Understand? Sharing. So you see, this is okay. Now, can anybody tell me?
Use sine.
Yeah, use sine 6 degree equal to
A over L.
A over L. Yeah, that's correct. A over L. So A is equal to L sine 6 degree. But make sure you are using degree, not radian. You are degree, not radian. So your calculator please change to degree. So 0.65 sine 6 degree. So this is a good question. He somehow need you to find amplitude yourself. He want you to find amplitude yourself. Sine 6 degree. So the amplitude is 0.06794. Okay. Meter. Because I already changed to meter kan? I already changed to meter. So meter. Alright. Okay, so now you know what value to put here. It is 0.06794. What's the omega then? Omega. What's the omega class? What's the omega class? Is there a way to find omega from here?
2 pi over period.
2 pi over period. Because we have period. When you have period, you can find omega. Okay? Okay? 2 pi over period. So, omega. So, 2 pi over period. Okay, so you can find omega. Okay, find omega. I can just substitute over here. Okay. So, what's the answer? What's the V maximum? So plus minus 0.2 0.2664, yeah, meter per second. Okay, is that correct? And then acceleration is at minimum, which is 0 lah, because at equilibrium. So 0 meter per second square. Okay, this one I put it somewhere. Okay, and then lastly, a student now use the same pendulum to measure the acceleration of gravity at their school. The length of the pendulum was half. The period is this. What is the experimental value of G at their school? So you want to find value of G. That means the value of G, yeah? The value of G over here. Value of G. So you see, you got this statement. Yeah, you want to find value of G, but yet it has this statement: the length of pendulum is half. So why suddenly he said length of pendulum is half? So that means it's comparing two situations. So you have length 1 and length 2. Can you get it? So that means kalau dia ada cakap length is of pendulum is half, that means dia ada length 1 and length 2. Wait. It give you this is the length 1, and then now you have length 2. Okay, so this is considered as length 1. This is considered as length 1. So now you have length 2, which is half of length 1. Okay. So what should I do? Question C. Okay, so find length 2 first, maybe. Half of length 1. Half of length 1.
32.5.
32.5, but I want in meter.
$0.325.
Okay, good. So we have length 2 already. So I got length 2, and then I got period. Oh, I can find G. So this the period of pendulum is 1.136. This one should be the new period, kan? Is the new period, kan? Because O period is, I see, this is the T1, using the L1, yeah? Using L1, T1, you get 1.62, 1.62. Okay, 1.62. Now you have T2, you have this is T2 lah. So you find value of G. So I think, yeah. So T2 is 1.136 second. So I think can find G already, So T equal to 2 pi square root L over G. So this is T2 L2. T2 L2. So okay, put in the value. L 0.325 over G. So what is the G value?
$9.94.
Okay. That's correct. I got the same answer. So 9.94 meter per second square. Okay. So almost near to 9.81. So our answer is correct lah. Okay, so that's the way to solve these questions. Any question? Okay, can follow, Alright.